good evening, one and all to present here. I am happy to welcome for the fifth day of online MATLAB training. So we started in the last session how we are going to use the various minimum and maximum function which we have in signed and unsigned integer. Then later we started how we are going to using strings in MATLAB. From the strings, we are going to combining the string, then we are going to convert it to lowercase to uppercase, then we have concatenated the string, we join the string with the help of str join keyword. Then we started the various type of functions from in MATLAB. We discussed some how we are going to using the local workspace and base workspace also. Then we know about it, little bit knowledge in anonymous function, primary function, and sub functions. We find it the value of the quadratic equation using primary and sub functions. Later, we started for the nested function and private functions, how we utilize the global variables, etc. Then finally, we know about it, how we are going to import the data. Data we are going to import it, either it is a JPEG format or any TXT format or any XLS format, etc. So the data also we can import it with the help of in MATLAB. Finally, we saw how we can import text data files with low level inputs. We show about it one suitable example, which we have the myfile.txt. Then we have three fields are there. One is time, then month, then which is the data. So the data we have 5 rows or 7 rows, 5 columns. That data also we discussed in the last session. So today we are going to start the next topic, which is the interesting topic from in MATLAB. So what is the topic we have from in MATLAB means that is plotting. So this is the topic is very interesting. We are going to do for a lot of examples with the help of in plotting. So from in MATLAB, we have the lot of many functions and commands. So this that can be used to create various type of plots. Either it is the two-dimensional or three-dimensional. For example, if we have any other applications means it supported only the limited plots, but in MATLAB we have lot of plots options are there. We can try to do minimum 10 to 15 plots, how it will create with the help of in MATLAB. I'll show about it. First we know about it, how we can generate it for this 2D plots. After generating the 2D plots, we know about it, what are the functions we have in 2D plot. So if we are going to generate one simple plot, this plot we have the x-axis. From this x-axis, we give for the label. The label is x-axis label. So what is the label name? The label name we can mention it distance. So distance is also mentioned it in the centimeter format. So distance, centimeter. So how we can insert this label from in 2D means we have the syntax. We show about it. We created for the label from the x-axis. Then from this y-axis also we have the label, that is the intensity. So intensity label we can insert from the y-axis. Again, from this y-axis we have the value of label. So here we have the label values are 1000, 1200, 800, 600, 400, 200. So it starts from 0. The same we have in the x-axis. We are going to give the tick mark label 10, 12, 14, 16, 18, 12, 22, 24 like. After given the X label and Y label, we are going to give the title of the plot. So how we can give for the title of the plot means it will give from the top position. Wherever we need for the title of the plot, we can use depends upon the user. Then again we want to add for this legend. How we can add from the legend where we want to add, either it is the top position from the right side, or either it in the top position from the left side, or if you want to add either from the left side of bottom, if you want to add either right side or the bottom. So wherever we need for this legend, that is also we insert from the two-dimensional plot in MATLAB. Again, we want to give for the tick mark in other axis opposite of x-axis and y-axis. So this type of symbols we can mention it, that is a tick mark. Whatever we need for this symbol, user can choose. Then we generated for the two lines from this plot. One line is the blue color. So this is the blue color, we can choose the line, then thickness, etc. Then another one line we can draw in the red color. With the help of the red color, we are going to choosing the data symbols also. So if we are going to compare between theory and exponent. So theory and exponent we give from here, that is the blue color means we have the data in the theory, then we can draw this type of line. Again, we are going to draw for the experiment symbol. So this is we can draw experiment symbol from red color, then that symbol also. So this is a simple diagram it shows in two-dimensional. How we can create this type of two-dimensional diagrams, we will show about it. Then we are going to know about it. What is the commands? We are going to generate the 2D plot means we have the syntax is plot. So plot is the command. From this plot, we can mention it. What is the vector of x? What is the vector of y? So here x is the vector, that is the one-dimensional array. Then y is also another one vector we can add. So both vectors must have the same number of elements. Then the plot command is also created with the help of a single curve with x values and the horizontal axis. Then y value is the vertical axis from the plot. Then the curve is made from the segments of lines that connect the points that are defined by x and y coordinates of the elements of two vectors. So we are going to follow the syntax or the command for we are going to generating the plot. Then again, we know about it. What is the data we have? Depends upon this data, we are going to generate the plot. So what data we have? We have the data is, we have the data that is the x-axis. So the values are 1, 2, 3, 5, 7, 7.5, 8, 10. So totally we have 8 values. Then y-axis also we have value. What is the value of this y-axis? 2, 6.5, 7, 7, 5.5, 4, 6, 8. So these are the values we have from the y-axis. So we are going to generate the plot with the help of in two-dimensional. So we know about it. What is the syntax? We are going to generate it for two-dimensional plot. The syntax is that is plot then x comma y. So if is this the generate the plot means once the plot command is executed, then the figure window opens in the following plot. What plot it shows? So we are going to try. So what it shows for the result? If we are going to write some simple code from the MATLAB. For example, we can start this MATLAB. After starting the MATLAB, we can try to write the given table data. The first data is that is the x-axis. X-axis we have 1, 2, 3, 5, 7, 7.5, 8, 10. Now we enter the value of x-axis. Again, we are going to write the value of y-axis. So y-axis we have 2, 6.5, 7, 7, 5.5, 4, 6, 8. So after adding this y-axis value, then we are going to generate the plot. How we are going to generate the plot means we can write plot x comma y. So then the plot is generated. So what is the plot diagram it shows? Depends upon the value. So it shows the plot is like this. So we have x-axis 1, then y-axis is 2, then x-axis is 2, then y-axis is 6.5, then again x value is 3, y value is 7, x value is 5, y value is 7, then x value is 7.5, y value is 5.5, x value is 8, y value is 4, x value is 10, y value is 8. So the chart or the plot is generated like this. Whatever we have the data, we are going to generate the plot. So this type of plots is generated. What is the given data we give? So the given data we give like this, x-axis this, y-axis this, then the plot is generated like this. So whatever we have the data, we are going to generate the plot. Then again, we have the another one example we are going to do with the help of 2D plot. Then how it will generated for this 2D plot means, so this is the diagram it shows after generating, which is the value we mentioned it from x and y. The next one is with the help of in two-dimensional. So we are going to add it for the line specifies in the plot. What type of lines we want to specify? The lines we are going to specify, either it is the solid symbol or either it is the dot symbol or either we need to draw for a dash symbol or either we want to specify dash and dot symbol. What is the line style we need? So we are going to choosing the specifier with the help of in line specifiers in two-dimensional plot. So this is a command we are going to add plot x comma y. Then what is the line specifier we need? Then another one option we are going to choosing the line specifier with the help of the color. What color we are going to draw the lines? Sometimes we are going to draw the line that is red color, green color, blue color. So if we know the direct color, we can add for this RGB. Then we can choosing either it is the RGB color or we are going to choosing for CMYK color. So CMYK specifier, cyan, magenta, yellow, and black. So which is the color we need, we can choose with the help of this specifier. Another one option, the specifier, we can add for the marker type. What type of marker we need? It's supported for the various type of marker, like if we need to choose plus symbol, so we can add the specifier is plus sign or circle symbol or asterisk symbol or dot symbol or square symbol or diamond symbol. So whatever we need for the symbol, we are going to choosing the marker type of specifier. So these are the options we have when we are going to generate the plot with the help of in two-dimensional. We tried some simple example with the help of in line specifier. If we need to choose a type inside the plot, what is the command as the string? Within the string, we can add for the specifier, we are going to type in any order you are going to write for the specifier. So specifier is the optional. This means none, one, two, or all the three can be included in the command. For example, we need to the solid blue line. It's connect the points with no markers. We can write plot of x comma y. Then we can add the solid line is connect in the red color. So no marker means we can mention it plot x comma y and or. So x comma y is represent for the x-axis and y-axis. R is specify the red color. Then we can write it for plot x comma y, then yellow color. Then we want to add for the dashed line is double dashed line with yellow color. So how we can write it? The command from the plot x comma y, then dash symbol, then yellow color. Another one example we can add for no line between the points. How we can add plot x comma y, then we can specify there is no line between the point means we can add for this asterisk symbol. Sometimes we are going to draw the green line dotted connect with the points which are marked with diamond markers. So how we can add it for this diamond markers with the help of so we can add for the plot with the green dotted line, connect the points which are marked with diamond marker. So we can add like plot x comma y, then green color dotted line with diamond symbol. So this is the various specifiers we can add in the two-dimensional plot. I'll show about it. whatever we have the data like here, then we have sales. So two data we have. From the first data, we can create year, then start with 1988. We can increment by 1. Maximum is 1994. So this is also another one way we are going to give the data. The previously we entered 1, 2, 3, 5, 5, 7, 5 like. But now we are going to add a for the starting year increment by 1, then up to 900, there is 1994. So how we can write it means the data it will generate like 1988, 1989, 1999, 1991, 1992, 1993, 1994 is the last value. Then we can give for the data for the sales. So the first data for the sales is 127, 130, 136, 145, 158, 178, 211. So if we have the sales data like this, we can write that is the y-axis is sales, what are the data we have. Then we are going to generate the plot. X-axis is year, y-axis is sales. That we are going to specify the dashed line with the help of red color. Then we can start with this asterisk mark symbol. So the same program we are going to generate in two-dimensional plot means what output we are going to expect that if we have the expected output is like we start from here. So we can try to do with the help of in MATLAB. So just we can enter here, then 1988 to 1994. Then we can add for the data is sales. So the sales data we can add 127, 130, 136, 145, then 158, 178, 211. Then we can generate the plot with the help of specifier. What specifier we can utilize? The year it shows with the help of in red color. After red color, we can show the like, so red color. Then specifier is this. Then what is the symbol we can choose? There is a star symbol we can use. This is the value it shows from here. That is 1988, 127 is y Yeah, so we started with the help of pie plot in two-dimensional. So we show about it, how we can add it for the specifier. The specifier we can add either it is the line color or dash, which is the markers also we can choose with the help of in specifier. So we show about it, this specifier. So that is the possibilities we can add, like that is the dash, red line, asterisk marks we can specify with the help of specifier. Then another one example, how we are going to create plot of the function. Whatever we have the equation from in mathematics or statistics, that statistics formula we are going to generate in the plot. How we can utilize the plot with the help of any mathematical equation means, for example, here we are going to consider the equation y is equal to 3.5 power of minus 0.5x. Then we have the cos theta value is 6x, cos of 6x for minus 2 lesser than is equal to x is lesser than is equal to 4. So that means how we are going to write the script with the help of the plotting means, the simple procedure we can start with the value is minus 2, then we can assume x-axis is start with minus 2, then maximum is plus 4, increment by 0.1 or increment by 0.01. So here we can creating the vector spacing of 0.01. So here x is equal to minus 2 followed by colon, then start value is the increment value is 0.01, maximum is 4. Again we have the y-axis. Y-axis is equal to the equation is 3.5 power 0.5x. So here 3.5, then power is the tilde operator, then minus 0.5 power multiply with x, then value of cos 6 multiply with x. If we can using the x value and y value in the given function, then we can try to generate the plot with the help of x value and y value. For example, from in MATLAB, we can try to do the same example, what output we are going to expect, then how the plot is generated. So here we have the x-axis is minus 2, that is a starting value, maximum value is 4, then increment by 0.01. Then y-axis is 3.5, then power 0.5 multiply with x, then cos 6 multiply with x. Then we are going to generate the plot in both value x-axis and y-axis. So what is the plot if generated means, the plot is generated the graph, like this is the graph is generated for we given x-axis and y-axis. So what is the formula we have? We have the formula is x we can start with minus 2 to maximum 4, increment by 0.01. Now the y value is 3.5 power minus 5 multiply with x multiply with cos 6 dot x means we have the chart like this. We want to choose the particular value, then minus 2, minus 3, increment by 4 is the maximum value. So whatever we have the equation, we can generate the plot with the help of in 2 dimension. So again, we are going to do for The another one example, how we can create a for the another generated this type of functions means it shows the suitable example for y of 3.5 power 0 x multiplied with cos of 6x start with -2 maximum is 4. It shows the result is from this -2 to +4. That is the maximum value increment by 0.01. So that is the function we have. Then we can generate the plot in 2-dimensional. Then another one example, we are going to create the plot with the help of the function. Like if the previous plot we give the space is 0.3. Now we want to give the 0.3 means here we can give the value is x value is -2, y value is maximum 4, then increment by 0.3. If we can give this type of value means how the graph or plot is generated, then what output we are going to expect with the help of in MATLAB. So here we can generate the plot like this. So here we can give the space between 0.3. So whatever we need to start with x, end with the maximum value, we are going to increment by 0.3 here. So there is also possibilities. We can generate the plot in 2-dimensional, whatever we have any type of equations. Then another one is how we can create a for this function of plot. So whatever we have the equation, the function of x. So here the equation y is equal to f of x. If we have this type of function, how we can generate it for the pie plot or plot means we can add it for f plot. Then what is the function? What is the limit value? So limit value also we can give when we are going to generate it for function plot. Then function we want to type in the string, then limits we can write it for the vector with the domain of x, and optionally we can give the limits of the y axis. Here we can give the value of x minimum and x maximum. Then x minimum and x maximum, y minimum, y maximum. That is also we can give this type of functions. So this type of function plot also we can generate either the value of the function and limit. So here we have the function is y is equal to x square plus 4 sine of 2x minus 1. So if this is the equation, we are going to generate the plot. What is the minimum value? What is the maximum value? What is the increment the value? So here we can try to generate the plot. The function plot is x square. So f plot x square, then 4 of sine 2x, 4 of sine 2x, that is multiplied with this, then minus 1. So that is the equation. This equation we can write it within the single quotation as a string. Then we want to give minimum and maximum of x-axis and y-axis. From this x-axis, we can give the minimum value is -3. Then the y value we can give for +3 is the maximum value. So x start with -3, end with +3. So how we can generate this type of function plot with the help of in MATLAB, then what output we are going to expect means we can write it the same equation. This equation, how we can generate plot with the help of in MATLAB. So we can start with MATLAB. From this MATLAB we can write function plot. So f plot, the equation is the string format. The numbers we can write it the value of -3 and +3. So what is the plot it will generate? This is accept the character as the string input features. So we can write that is star this, then instead of f plot is 10. So we can start write it like this. There is a double quotation that is asking for the symbol. So we can write it here. That is the double quotation is the string. So we can add. So this type of output we are going to expecting whatever we have the value of, whatever we have the plot which we have for the multiple graph also we can add whatever we have the functions. I will show about it, the function plot in future or the later slides. Then another one option, we have the multiple graphs we can draw in the same plot. So we know the plot, we have only x-axis and y-axis. Now we can try to draw for multiple graphs in the same plot. So here we can give y is versus of x, then b is versus of u, then h is versus of t. So these three verses we can try to do the plot three graphs. By default, from the MATLAB, we can make curves in the different colors. But if you want to additional curve, it can be added. The curve is also can have specific style. That style also we are going to adding specific specifiers after each pair. So first x and y we need for the hyphen symbol, that is a dashed symbol, then blue color, then u and v dashed symbol, then red color, then t and h green color followed by column. So this is the specifier we can add in multi graphs in a same plot. Just we can show about it. We can try to do in multi-graphs, which is the same plot we can generate. The equation is y of 3x power 3 minus 6x plus or plus 6. Then the second derivative is the values start with 2, maximum is lesser than 4. We can generate the graph like vector of x, then vector of y with value of each x, then vector of y of d, this value of the first derivative, then vector of y dd, the value of the second derivative. Then we can generate the plot like this. Three graphs we are going to generate. It shows the result is like this: green, red, and blue. How we can generate that for this type of multi-plot in a single program. So our same plot we are going to generate. How it will generate it? Then it shows the result with the help of in MATLAB. We are going to generate the same program in MATLAB means what it shows, the plot it shows, this is the color it shows from this MATLAB. Like so blue color. So blue color we can mention it. So the value of x-axis and y-axis. Then red color, there is a dash symbol. It shows in the red color and x and y of t. Then the black color, that is the k, x color and y dd. So this is the way we are going to generate multi-graph and say multi-graph in the same plot. So that is we can try to generate. Then next one is how we are going to using for hold on, hold off command. So this is also very interesting when we can add it for any type of multiple graphs in the same plot. So hold on means which we are going to working in the current plot and all axis properties so that subsequent plot commands add to the existing plot. Then hold off means we can return the default mode whereby plot commands erase the previous plots and reset all axis properties before drawing the new plot. We will show about it, how it's difference for this hold on, then hold off. Here we have the equation is 3x3 minus 20x plus 10. The derivative is minus 2 lesser than x lesser than 4. How it will generate in multi graphs in the same plot means it shows the result whatever we have the value, then what output we are going to expect for this is the graph means it shows like which is we are going to using for the current hold and hold on and hold off. The same code we can try to do in MATLAB. Then what diagram we are going to expect means it shows the result is like this. So which is the hold on, which is the hold off, it shows the result which is we can given the input, depends upon the input we can choose the first graph is created, that is the hold on, then two more graphs are created after we have the plot x and So we generated for the multiple graph in a same plot. So when we needed for the hold on and hold off. From the two-dimensional plot, we have various formatting we can utilize. What type of formatting we are going to utilize means we can add it for the title, adding the label. We can do for the various formatting of the plot. We can add the title, we can add the label. We are going to changing the axis value. We are adding the legend. We can add the text block. Then we are going to add for the grid also. So this is the various formatting we can add whenever we can add for any type of two-dimensional plots. Here we can try to do the formatting commands. The plot is the common formatting command we can add. This is done with help of the command window. Then the formatting plot interactively in the figure window. The formatter clicking the plot and using the menu to make change if whatever we need to for the details. Then another one is we are going to add for the title. How we can add the title from the plot means we can give the title, then string. This string, we are going to add the string as a title at the top of the plot. That is a title. When we can add for any type of label, either it is x-axis or y-axis. How we can add for this x-axis means x label, then string. Add the string as a label to the x-axis. Then we are going to add for the y label, add the string as the y label of the y-axis, like y label string. Then we can know about it, what is the minimum and maximum limit from the axis, that is we can give, that is x minimum, x maximum, y minimum, y maximum with the help of axis. For example, we can add the legend. We are going to create the legend, either which is the position we need, that location also we are going to add. The legend, we can choose the location, which is specify the mouse. Then text also we can choose either x-axis or y-axis, that string and the plot at coordinate value of the x value, y value relative to the plot axis. Then get text we can using for the places the string on the plot. When the command it will execute from the figure, window pops and the text location is also clicked with the mouse. I'll show about it some example. Then we easily understand how we are going to formatting the plot with the help of in two-dimensional. Here we have the x value and y value. From this x value, we have the values are x is equal to 10, increment by 1, maximum 22. This is creating the vector for plotting the theoretical curve. Then we have the y value. The y values are, we are going to write y of 95,000 divided by x of 2. This is creating the vector y for plotting the theoretical curve. Then we create the vector with the coordinate of the data points like xd 10, 2, maximum 22. So here, this is we can coordinate value of the data points. Then we have yd. This is creating for the vector light intensity from the data. Then we generate the plot from x value and y value. The line width is 1.0. The hold on the plot we can create a xd and yd, red color, o symbol, that is a round symbol, hyphen, line width, then 1.0, marker size is 10, then hold off. So how we can generate a this type of plot means it shows like this is the diagram it shows after generating for the plot. So before we know about it, what value of light intensity we have. We can give for the label, then format, axis value, text, some legend also we can add from this plot. First one is x label we can give. X label is distance, y label is intensity, then title we can give for the font name, then font size, then axis value we can give. After giving this axis value, we are going to give for the text, the comparison between theory and experiment. The edge color also we can give. Then we can give for the line width. Then we can add it for legend, theory, experiment, and 0. So we can add this type of light intensity we can do for the formatting. For example, the same program we are going to execute with the help of in MATLAB means it shows x-axis label is distance, y-axis label is intensity, then we can give the legend, then title, then draw the line, the comparison between the text also we can give. It will create it for like this. So the same code we are going to run with the help of in MATLAB means what output we are going to expect, then how it shows for this type of output with the help of in MATLAB. So we can try to do the same program in MATLAB. So it shows the result with the help of in MATLAB where the label, the title, everything it will display with the help of in legend, then what is the title, everything it shows. You can follow it. What is the procedure we are going to follow it? We can give the various format. Again, so the formatting it shows after generating the graph, we can choosing the insert menu. We can change whatever we want to start the point, then using the figure axis, current object properties in the edit menu, we can change which is the label we needed, then which we want to change. For example, from the insert menu, we can change what we have. From the MATLAB, it will generate it for the figure like this. From this figure, we are going to change insert X label. Then we can change it here. So we change it, the value is MCA, or we can choose MATLAB. Now the X label is changed. If you want to change Y label, we can choose the Y label. So that is practical. So we can type practical, it will change the Y label. Then if you want to change for the title, we can choose the title. It shows this is for data, data for MATLAB. So the title it will change. Then we want to change for this legend. So legend we can change here. The legend it shows data 1 and data 2. Then we are going to change for the color bar. So if we need the color bar also we can add it. Then if we need to for this line, so line we can try to draw wherever we need for the line. Then arrow mark if we need it, the arrow mark also we can insert. Then text arrow, that is also we can insert. Then we can add for the double arrow symbol. So that is also we can insert wherever we need. Then text box, we can add the text box, which is the text we need. So that is also we can add. Then we can insert rectangle symbol, that is also we can add. Then if we need for the ellipse symbol, so ellipse symbol also we can insert it. Then axis, so that is also we can add it for the axis, which is the diagram we are going to add from the axis value here. Then we can insert the light, so wherever we need for the light symbol, that is also we can insert it. So this is the possibilities. We can add it whatever. After generating the plot, we can insert anything if you need it. From the toolbox, we have this type of option is also there. So that is also we can do with the help of the various purpose of from after generating the plot. Then that is a simple, easy way we are going to generate plot with the help of in MATLAB. After generating the plot, we are going to format it. What type of format we need it, then we can generate it. So here it shows for the various plotting types. What type of plots we are going to generate. So here we can define the x by specifying the range value for the variable is x. Here the function is y is equal to f of x. Then the plot command we can utilize plot x comma y. The simple function of the plot is y is equal to x. The range values are start 0 to 100, increment by 5. If we have the data like this, how we are going to generate the plot with the help of the plot function, what output we are going to expect with the help of in MATLAB. So the same program we are going to compile with the help of in MATLAB, what output we are going to get. So we have the values are x value is 0, start with 0, increment by 5 up to maximum 100, then plot we can generate x to y. Y is equal to f of x. So that is the equation we have. We can generate this type of plot. The simple plot function we can utilize, then we are going to generate. Then we can do another one plot. What are the values are there? If the equation is y is equal to x power 2, what is the value of x? X means we have 1 to 10. Then we have the values of y-axis is minus 100 to plus 100, increment by 20. Then the plot we are going to generate x comma y. So how it shows for the result? Whatever we have the data, this data we are going to generate with the help of in MATLAB. So what plot is generated, then after generating the plot, what result it shows? The result it shows like this. Start with here, then minus 100 from the x-axis, plus 100 is the y-axis, that is the increment by 20, then minus 100, minus 80, minus 60, minus 40, minus 20, 0. 20, 40, 60, 80, 100. So increment by 20, then we have x power 2, x comma y. After adding this, we added for the x label. So x label of x-axis, then y label is the y-axis. We are going to insert. So that is y-axis. Then if you want to give for the title, so what is the title if you want to give? The title we can give for, that is the plot. So we can give the title is plot. Then we want to add for any text boxes here, insert, then text box, we can draw from here. So this is the middle position. So this type of text box also we can add from which location we need. So that is the way we are going to generate this type of plot, what data we have. Then another one example, we can generate for the matplotlib x power 2, increment by 5, maximum is 100, minimum is minus 100. Then another one example, we are going to adding the title, label, grid lines, scaling on the graph. How we can utilize this type of formatting means we have simple syntax we can add, either it is the x label or y label command. It generated for the labels along x axis and y axis. We are going to using the title command, we can give the title. When we want to add for the grid lines, we can add for the grid on command. Then axis equal command which allows for generating the plot with the same scale factors and the spaces on the both axes. Then the axis square command we can generate it for the square root. For example, we can generate one simple plot. What is the value we have the plot means we can give x is equal to 0, increment by 0.01, maximum is 10. So that means how we are going to generate the graph means y is equal to sine of x. Then that is the y-axis value. Then x-axis value is sine x. Then plot we can generate x label is x, y label is sine x. Then plot we are going to generate what is the data we have x-axis and y-axis. We want to show about it the grid lines, so we can on grid on, axis is equal, then title is sine x graph. So this is the title, this is the x-axis, this is y-axis. We can generate the plot. Then we want to show about it the grid line also. For example, the same program we are going to run with the help of in MATLAB. How the diagram is generated. After generating the diagram, what output we are going to expect. So we So we generated for the plot. So what plot we are going to generate means it shows that is the x-axis value, y-axis value, then title, then it shows the value of y is equal to sin x, then the grid layout also it will display from here. So that is the way we are going to generate the plot. After generating the plot, we can show about it the grid lines with the help of the formatting. Then another one example, we know about it, how we can add it for the drawing multiple functions on the same graph. So we have the equations are y is equal to sin x, g is equal to cos x. So then we have two functions are there. We can generate the plot, okay, x comma y and g. That is the first pair, x and y we are going to compare. The second pair is x comma g we are going to compare. Then there is the dot line. Legend also we can add sin x and cos x. So defaultly it will add the legend from the right top position. If you want to change the position, that is also we can do with the help of and formatting from MATLAB. So the same program we are going to run with the help of in MATLAB. What the plot is generated, how the output it shows with the help of this plot means the figure it shows like, so from here x-axis and y-axis, the sin x and cos x is generated the plot like this is. So multiple graph in a single plot we are going to generate. Then another one example we know about it with the help of in plot, we can setting the color, which is the color we need. We can add either it is the RGB format or CMYK format. Sometimes we can show about it the lines in the either white color or black color. So white color means we can utilize the symbol is W. Then black color we can utilize for K. Then RGB means red, green, blue. Then CMYK, cyan, magenta, yellow, and black. So that is we are going to setting the colors on the graph. The next one is major, we know about it. How we are going to add or how we are going to generate the plot which we have in the polynomial equations. So the polynomial equations means the combination of exponent and coefficient. So how we can generate it for this polynomial equation? We have the two polynomial equations are there. Equation 1 is 3x power 4 plus 2x power 3 plus 7x power 2 plus 2x plus 9, that is f of x. Then g of x means 5x power 3 plus 9x plus 2, that is the two equations are there. We are going to generate the plot with the help of in polynomial equation. That is the equation we want to write for the y-axis. Then g-axis we can write it like this. Then x-axis start with -10, maximum 10, then increment by 0.01. We can generate this x comma y is the red color, x comma g is the green color. If two polynomial equation we are going to generate, then how the plot is generated. After generating the plot, how it shows for the colors. So like we can utilize the same MATLAB. From this MATLAB, we are going to generate the graph, either that is the red color and green color. So the graph or the plot it shows like this. So the first equation is the red color equation. It shows x and y. The equation is 3x power 4 plus 2x power 3 plus 7x power 2 plus 2x, then 9. Then another equation is 5x power 3. Then we have 9x plus 2. So this is it shows this type of plot, whatever we have the polynomial equations. Then another one we know about it, how we can set x value and y value. That is the syntax we can utilize. The minimum of x, the maximum of x, or minimum of y, maximum of y. So in both we can mention it. If here we have the value is x is equal to 0, 0.1 is the increment, 10 is the maximum, y is exponent of minus x multiplied with sine of 2 power x plus 3. Then plot we are going to generate. The axis is 0, 10, minus 1, plus 1. So user can define what is the axis value we need. Depends upon the axis value, the plot is generated. So how the plot is generated for, that depends upon the value, the given value we can try to do, the plot is generated. The user can choose the start x value is 0, that is the x value. Then y value it shows maximum is 10. So that is the x value is maximum 10. So it shows x value is maximum 10. Then user can define x value is y start value is minus 1, maximum is plus 1. So the diagram is shows minus 1, then maximum is plus 1. So that is also user can choose what is the value for the minimum and maximum. So this is the way we are going to set the axis value of x-axis minimum, then y-axis minimum, or y-axis maximum, x-axis maximum also. Then we can try to do the same program with MATLAB, means it shows the result like this. Again, we have the another one option. Whenever we can utilize this type of plot, means how we can generate it for subplots. So with the help of the subplots, we can create, with the help of the command is subplot commands. How we can generate it means, with the help of the subplot, we can add it. So what we have, the m value and n value. So here we can represent m value is, m and n are the number of rows and the number of columns. So that is we can add from the plot. Then we have the p value. So p is specified from the plot. So where we are going to put a particular plot. For example, here we have y value. Y is equal to e power minus 1 multiplied with x sine of 10x. Then another one is we have e power minus 2x sine of 10x. If this type of value, how we are going to generate it for in subplots. So here we have the two equations. One equation is this, another equation is this. From the equation, exponent of minus 1 multiply with star, the multiply with sine of 10 power x. Then subplot we want to mention it. This is we are going to split at 1 row 2 column. So this is we want to display in the first one. Again the subplot is, that is the first row, second image in the second column. So we can give the label of the x-axis, y-axis label also we can give. Then start with minimum is 0, maximum is 5 from the x-axis. Then y-axis is minus 1 is the minimum, plus 1 is the maximum. So this is the way how we are going to add the subplots. The same code we can run with the help of in MATLAB, means how it shows for the subplots. For example, the subplots it shows, this is the way it will generate it for the subplot. Then the output it shows after generating the plot. This is the output it shows like this. What it shows? So it shows for which is the value we are going to generate. The values are x-axis and y-axis. The subplots are the first only 1 row 2 column. Then first image is this. Then second image is we can mention it. So that is also we can define with the help of in the subplot. We can mention it. 0 is the minimum value, maximum is 5 from the x-axis, then 0 is minus 1 is the minimum value of y-axis, the maximum value is plus 1 in two subplots. So that is also we can generate with the help of in subplot function. Then another one very interesting, we know about it. So with the help of in subplot, we are going to use it, the various graphics. So that is very interesting one, how we can add the graphics from in MATLAB. From the plotting and graphics, the capabilities of drawing the bar charts, drawing the contours diagram, then we can add for three-dimensional plot. So that is 3D. So 3D also we can do it. We are going to draw the contours, then we are going to draw the bar charts. So how we can draw this type of graphics in MATLAB means we know the simple function, we know about it, then we are going to add this type of plots from in your MATLAB. Just we can add for the first one is how we can draw for the bar charts from in your data. The bar chart means this type of bar command is draw two-dimensional bar charts. Then we are going to do some simple example. We have the data from your classroom. Totally 10 students are there. Then from the 10 students, we have the percentage of the marks like 75, 58, 90, 87, 50, 92, 75, 60, and 95. These 10 students from the class, we show about it, the marks percentage from here. If we have this data, how we are going to generate it for bar chart. So the simple procedure, we can generate it for the bar chart with the help of the bar function. So here we have the x value is totally 10 students are there from 1 to 10. Then y axis, we have the percentage of the marks students. Then we can generate it for the bar chart. We can add the bar function x of y. Then x label we can give student, y label we can give for the score. Then the title also we can mention it first semester. We can print is graph.eps. So that is the file extension we are going to store, which is the bar chart is generated. So whatever we have the data, we are going to generate it for the bar chart. Then what output we are going to get for this bar chart means it shows the result like this. From MATLAB, we are going to compile or we are going to write the code. Then what it shows, yeah, it's generated for this type of bar chart. Totally 10 students are there. So the x-axis is student. So 1 to 10. Then we have the score from 0 to 100. So that is the percentage it shows. The percentage are 0 to 100. Then each value it shows from the generation of the bar chart. So the title also we can mention it. That is the first semester. So the title it shows in the first semester. So this is the way we are going to generate it for the various type of graphics with the help of in MATLAB. Then another one, how we are going to draw for the concave images. The contour means there is a line of function of two variables. It's the curve along which the function has a constant value. Contour lines are used for creating contour maps by joining points of equal elevation above a given level. That means mean sea level. Then MATLAB is also provided for the contour function. That function we can utilize, then we can try to draw it. We are going to join, that is the contour function. Then this drawing contour function, we can using this mesh grid command. It is used for generating the matrix of elements. Here we are going to generate the function is g of f comma y, f of x comma y, then where the conditions are -5 lesser than +5, then -3 is lesser than +3. The increment is 0.1. So that means how we are going to generate it for this contour diagram. Here we can add for the syntax is mesh grid. We can start with -5 to +5. The increment value is 0.1. Then -3 to +3. This increment value is -1. We are going to assigning the function with the help of the function is x squared plus y squared. Then here we can add for the mesh grid g of x squared plus y squared. We can add the contour function contour of x comma y comma g. Then we can print it. So which we have the contour diagram, it will print it. I will show about it. The same code we can run with the help of in MATLAB. So what output we are going to expect, then what it shows. So it shows the diagram is like this. The contour diagram it shows. We can mention it. The value is -5 is the x-axis, the minimum. The maximum is +5. Increment by 0.1. Then y-axis -3 is the minimum. Maximum is +3. Increment by 0.1. Then the function is g of x squared plus y squared. The contour diagram it shows 0x y g. So that is the diagram it shows for the contour with the help of in contour function. So this type of animations or this type of graphics we can generate in MATLAB. Then another one example it shows for, then other contour we can add the showing the text, then text step, then level. That is we are going to set, then it shows that is the title of the set. That level also we can generate. The same the code we are going to run. How it will drawing the contour with the help of in MATLAB means it will generate it like this. So the line of value also it shows this type of diagram like. So the level of step, then we can increment by 2, etc. So this is we can add it with the help of in contour diagram. So here we can mention it, which is the text. Then what are the level of step also we can multiply with 2. So it shows 10, 20, 30. Then what is the maximum value? We mentioned it 5. So it shows maximum in the range of the 5. So this type of contour images or contour diagram also we can generate it. Then three-dimensional plot. How we can generate it for this three-dimensional plot? So from two-dimensional we can using only x and y, but in three-dimensional we are going to add one more variable. So before we want to define it, then we can using for this three-dimensional, the command is mesh grid. With the help of this mesh grid, we are going to create the surface plot with the help of in surface command. You can remember what type of command we are going to generate it for this type of three-dimensional plot means here we can create it in three-dimensional, that is the mesh grids, we can mention it in three values. So that's why we can create it for this is the three value after it's generated for in three-dimensional diagram. So how it will create it for this three Yeah, so we are going to generate it for the contour diagram. Then we are going to generate it for three-dimensional plots. So this is the procedure. We can mention it, mesh grid, and what is the value we are going to generate it for the three-dimensional. What is the formula? Then suffix we can generate it. So we are going to generate it this type of three-dimensional diagram. How we can generate it for this type of three-dimensional diagram? with the help of in MATLAB, we can try to do the same program in MATLAB, what output we are going to expect. We are going to expect this type of outputs in three-dimensional diagram. So what is the value we mentioned it from the mesh grid? Okay, here -2 to +2. Then increment value we can calculate it for x power multiply with the exponent of -x⁻²- y⁻x⁻². So three axes we have x-axis, y-axis, and z-axis like. But from here x-axis, y-axis, and z-axis. So x we have -2 +2 increment by 2. Okay, there is a -2 -1 0 +1 2. Then y-axis also we have. Then g we have for x⁻²- y⁻2. So this type of three-dimensional diagram also or three-dimensional plots also we can generate with the help of in MATLAB. Yeah, now today we discuss for four different type of major topics we discussed. What is the topics we discussed in this session? One is we are going to generate it for 2D plot. That is a two-dimensional plot. From two-dimensional plot, we created for the various axes. Then we can mention it, the value of the specifiers, either it is the points or dashed line, solid color, line color, etc. Then we are going to generate the plot with the help of the function. The function plot also we can generate it. Then in a single graph, we can multiple graph in a same plot we can generate it. Then we can generate it for the bar chart. Then again we generated for like drawing the contour image. Finally, we discussed 3D chart also we can generate it. If do you have any doubt or any clarification, please write from chat box. Whatever you have any doubt or any clarification, please write from chat box. Yeah, if there is no doubt means please fill the attendance form. So attendance form is posted from the chat box. Yeah, please fill the attendance form. Attendance form is posted from the chat box. Who's attending? Okay, more than 5 sessions. Totally, we conducting 6 classes. Who's attending more than 5 classes? We will send the certificate. So please fill the attendance form. So don't forget filling the attendance form. Attendance form is mandatory to all participants. If do you have any doubt, please write from chat box.